Hi folks, welcome to my channel, The Average Dermadoc. Let's begin the show.
Mast cell. What is a mast cell? Coming to its definition, it is a bone marrow derived large mononuclear tissue resident innate immune cell with special secretory properties. What do we mean by this definition? Even though they are derived from bone marrow, these mast cells won't like to roam in the bloodstream along with other blood cells. Soon they will reach the tissues and there they will settle down as tissue resident innate immune cell, where they will show special secretory properties whenever they are activated. Coming to its embryology, as the definition says, these mast cells are derived from bone marrow hematopoietic stem cell. These hematopoietic stem cells gives rise to myeloid stem cells, which in turn gives rise to mast cell precursors. These precursor cells are immature cells. What do we mean by immature mast cell? They won't contain any granules. These mast cell precursors, soon after formation, they will leave the bone marrow and reaches the bloodstream. As I already told you, these mast cells won't like to roam in the bloodstream. Soon they will reach tissues and becomes a mature cell. Now what is a mature cell? A mast cell with full of granules. How this immature mast cell becomes a mature cell? By the influence of stem cell factor and interleukin 3 present in those tissues, finally becoming a mature mast cell in the tissues. Based on where this mast cell settles, in which tissues and what they secrete, it is divided into two types. One is type 1 mast cell. They are present in connective tissue CT, where they secrete kinase and tryptase, both these enzymes. Another one is type 2 mast cells, T for tryptase. It will secrete only the enzyme tryptase, located in mucosa of GI tract, respiratory tract and conjunctiva. Where type 1 mast cells are located? In the connective tissue, where in the submucosa of GI tract, respiratory tract, and mainly as a dermatologist you should know that in dermis, type 1 mast cells are abundantly found in the papillary dermis, around blood vessels, nerves and appendages. By this, what we can derive? Mast cells are located both in mucosa and submucosa of GI tract, respiratory tract and in the dermis of the entire skin. By now we can understand that a mature mast cell with granules will never be found in the bone marrow or in the bloodstream. What if granulated mast cells are found in bone marrow or bloodstream? It is obviously an abnormal condition. What do we call that abnormal condition? I will answer at the end of this topic. Coming to its demonstration. How a mast cell looks on routine HND stain. A routine HND stain cannot stain granules. So the entire cytoplasm will look pale or empty with central dark round nucleus, giving rise to a fried egg appearance. Here you can see this is a fried egg with central dark round egg yolk, that is yellow part of the egg, with pale empty white, that is egg white. Cytoplasm is compared to egg white. This is actually an omelette, half boiled omelette. Why they are calling it as fried egg appearance, I don't know. Now coming to immunohistochemistry. Most specific immunohistochemical marker of mast cell is tryptase. Why? Both the mast cells is secreting tryptase. Here you can see. In addition, only type 1 mast cell is secreting kinase also. So tryptase is the most specific immunohistochemical marker. And c-KIT. c-KIT is stem cell factor receptor. It is also called as CD117, found on the surface of mast cells. Coming to special stains. As we have already seen, a routine stain can't stain granules. Only a special stain can stain, that too metachromatically. What is meant by metachromatia? We will use one color stain and the resultant stain will be of different color. As we can see here, we are using toluidine blue, but it will stain granules to violet or reddish purple. Actually, it has to stain blue only, but it is staining into violet or reddish purple color, some other color. That is called metachromatia. If it is staining the same color of the original stain, it is called orthochromatia. Now here, mast cell granules are metachromatically stained with special stains like toluidine blue, GM-SA stain and Wright stain, which stains granules to reddish purple color. All the granules will be stained with reddish purple color so that it will obscure nucleus sometimes. In special stains, granules may obscure the nucleus. Coming to electron microscopy, mast cell is a round to spindle cell with large long villi at the periphery. Here you can see round to spindle cell with large long villi at the periphery and a central round to oval nucleus with numerous membrane bound electron dense granules in the cytoplasm. This is the structure you have to draw when you are asked about a mast cell. These mast cells got their name from the word Mastung, which means fattened or well-fed state, because these mast cells are with full of granules in its cytoplasm. That's why they are called as mast cells. Coming to triggers of mast cell and their receptors. There are so many triggers for mast cells, which are classified into immunological and non-immunological. Coming to immunological triggers, the main and most important trigger here is IgE antibody. This E stands for epsilon. That's why its receptor is named as Fc epsilon R1 receptor. Mast cells will contain so many Fc epsilon R1 receptors, which have high affinity towards Fc end of the IgE antibody. We all know that each antibody will have Fc end and two Fab ends. Only one Fc end and two Fab ends, where antigen comes and binds. These are Fc epsilon R1 receptors on mast cells. Whenever a true allergen like pollen enters the human body, it will go and bind to Fab region of two adjacent IgE antibodies. Not just one IgE antibodies. Why it will bind to two? To cross-link those two antibodies, which in turn cross-links this Fc epsilon R1 receptor, which have high affinity to Fc end, which leads to activation of mast cell and its mediators are released from mast cell. This is a classical example for type 1 hypersensitivity reaction, which is mediated by IgE antibody. This is the story of how a true allergen comes and binds and activates mast cell. Coming to other immunological triggers, our own body will develop antibodies against this IgE antibody, which is attached to mast cell. Same like pollen, this anti-IgE antibody also enters the produced inside the human body. This anti-IgE antibody will come and bind to two adjacent IgE antibodies at their Fab end, and the same story continues, which leads to activation of mast cell and its mediators will be released. Same like this only, anti-Fc epsilon R1 antibody also goes and binds to two adjacent epsilon receptors, which leads to cross-linking of these two receptors, leading to activation of mast cell. Clear? IgE antibody in response to true allergen. Anti-IgE antibodies comes and binds to IgE antibody and will activate mast cell. Directly, antibodies will act against epsilon receptors and they will also activate the mast cell. Whenever you are asked about what are the reasons for autoimmune chronic spontaneous urticaria, you should mention two antibodies. One is against IgE, one is against its receptor Fc epsilon R1 receptor. Whenever you are asked what are the associated diseases for chronic spontaneous urticaria, you should answer Hashimoto's thyroiditis, rheumatoid arthritis. We will see how these autoimmune diseases are linked with autoimmune urticaria. In case of Hashimoto's thyroiditis, our own body will develop autoantibodies against thyroid peroxidase and thyroglobulin. Mast cell will have receptor for IgG antibody, that is G for gamma, Fc gamma R2 receptor. So it will come and bind to this receptor, ultimately activating the mast cell. Same in case of rheumatoid arthritis. We all know that RF factor, rheumatoid factor will be formed, which is an anti-IgG antibody, which binds to IgG antibody. This complex goes and binds to Fc gamma R2 receptor, leading to activation of mast cells. Whenever there is autoimmunity in our body, it will lead to formation of immune complexes. We will see how many immune complexes can be formed here. What do we mean by an immune complex? It is nothing but antigen plus antibody. We will see how many immune complexes are formed here. This true allergen acts as an antigen and this IgE antibody is the antibody. They will combine to form one immune complex. Here this IgE antibody acts as an antigen for anti-IgE antibody. This antigen plus antibody will form another immune complex. Here is one more immune complex. Here is another one. Here is one more immune complex. All these immune complexes will activate classical complement pathway, leading to formation of anaphylatoxins C3A, C5A, which have their own receptors on mast cell, leading to activation of mast cells. In case of infections, infestations and venoms, sometimes they will activate alternative complement pathway, leading to activation of complement system, directly forming C3A, C5A anaphylatoxins, which will activate the mast cell via their own receptors. Clear? Now we will summarize what are all the immunological triggers of mast cell. First and most important one is IgE antibody and antibodies against IgE Fc epsilon R1 receptor. Then IgG, antibody against IgG. Simple. Clear? Immunological triggers of mast cell. Then coming to non-immunological triggers. What do you mean by non-immunological? It does not require IgE antibody. They have their own receptors. All non-immunological triggers have their own receptors. They will go and directly activate mast cells. Example, pseudo-allergens. A true allergen requires IgE antibody, but pseudo-allergens does not require IgE antibody. Cytokines, chemokines, physical stimuli, hormones, estrogen, gastrin, ACTH, TSH. That's why whenever an urticaria case comes to us, we will evaluate thyroid profile to check TSH levels. This TSH will also stimulate mast cell, leading to urticaria. During menses, pregnancy, emotional stress, all these will lead to hormonal imbalance. These hormones have their own receptors on mast cell and will activate mast cell, leading to urticaria. Neuropeptides, VIP, substance P, infections, infestations, venoms, they can activate alternate complement also. They can directly activate mast cell via toll-like receptors also. Stem cell factor acting via KIT receptor. This stem cell factor won't cause any urticaria, but this is important for growth, survival and differentiation or maturation of mast cell. This we have already studied in the beginning. Here, an immature cell will become a mature mast cell developing granules only after exposure to stem cell factor, which will act via KIT receptor. Now we have seen about various triggers of mast cell. What happens if these triggers activate mast cell? Upon activation by various triggers, mast cells will secrete its several mediators via degranulation. Degranulation means preformed mediators will be released immediately from granules. Examples are histamine, serotonin. These are biogenic amines. Serotonin is also called as 5-hydroxytryptamine. Heparin, hyaluronic acid. These two are proteoglycans. Chymase and tryptase. These two are serine protease enzymes. Neuropeptides like VIP and substance P. These are all the list of preformed mediators which are immediately released upon activation. Now we will see some mediators are synthesized freshly, newly. That's why it is called de novo synthesis. Because it takes time to synthesize, it will be released with a delay. What are the examples of de novo synthesized mediators? Prostaglandins like D2, leukotriene, B4, C4, D4, cytokines and chemokines. Growth factors like stem cell factor, vascular endothelial growth factor, platelet activating factor. These are all the examples of mediator which are synthesized newly and then released with some delay. Coming to applied aspects. I have asked you a question in the beginning. What do we call that abnormal condition where granulated mast cell will be seen in blood and bone marrow? That is nothing but systemic mastocytosis, which is meant by abnormal mast cells accumulating in any of the internal organs. We will call it as systemic mastocytosis. If they get accumulated only in the skin, it is called cutaneous mastocytosis. In systemic mastocytosis, there is an aggressive form called mast cell leukemia, where granulated mast cell will be seen more in number in bloodstream and bone marrow, where we shouldn't see any granulated mast cell at all. It is because of KIT gene mutation. KIT receptor is main thing to get influenced by stem cell factor, and it will lead to maturation of mast cell. Here, cutaneous mast cell is also known as urticaria pigmentosa. Abnormal mast cells will be more in number, which we can see with our eyes like brown patches on the skin. If we stroke that brown patch, mast cells will get stimulated and there will be formation of wheals on that stroked area, on that patch. That's why it is called urticaria pigmentosa. Urticaria developing on the pigment. Sometimes systemic mastocytosis will present with urticaria pigmentosa. That sign is called as Darier's sign. On stroking that pigmentary change, if you develop wheal, that is called Darier's sign, seen in cutaneous mastocytosis. Mast cell activation syndrome, where the threshold to activate mast cell will be very, very low. Anaphylaxis, allergic asthma, allergic rhinitis, angioedema. To know all this, you should see my video on type 1 hypersensitivity reaction. Urticaria. Finally, what are the types of urticaria? Based on duration, if it is less than 6 weeks, it is called acute urticaria. If the wheals are coming and the duration is more than 6 weeks, then it is called chronic urticaria. Acute urticaria can be idiopathic. We can never find what is the cause. It may be due to infections, infections like upper respiratory tract infections, genital urinary tract infections, GI infections. So empirically we will give a course of antibiotic when our urticaria case comes to us. Same infestations, mainly worm infestations, helminthic infestations. That's why we will give albendazole to urticaria patients. True allergens and pseudo allergens. What is the difference between a true allergen and pseudo allergen? We have already seen that a true allergen will come and bind to IgE antibody and it will lead to stimulation of mast cell, whereas pseudo allergen does not require any antibody. It will have their own receptor. It will go and directly activate the mast cell. A true allergen, for the first time, it will be sensitizing our body so that we won't suffer from any allergic reactions for the first time. But if a pseudo allergen enters our body, even for the first time, it will stimulate the mast cell and will cause allergic reactions. Clear? We will see what is the difference between an antigen and a true allergen. Antigens like viruses, bacteria, which are a foreign to us, is dangerous to each and everyone. It is dangerous to you, dangerous to me. It will have the capacity to stimulate our immune system. But normal immunity will develop against those antigens and they will give protection to us for a lifetime. For example, if we suffer from chickenpox, we will suffer only once. We will never get chickenpox again in our entire life. Whereas true allergen is also an antigen only. It will have the capability to stimulate our immune system, but it will stimulate abnormally, which will lead to hypersensitivity reaction, leading to allergic reactions. Only for the first time we will be spared. Suppose if someone has allergy to peanuts, for the first time if he eats peanuts, he will be absolutely safe, nothing will happen. But it will stimulate immune system and it will sensitize that person. From second time onwards, immediately he will develop allergic reactions to that peanuts. For his entire lifetime, he should never eat peanuts. That is the only solution. That is to avoid that trigger, to avoid that true allergen for lifetime. What is safe here, allergen or antigen? Antigens are safe. It will suffer us only for the first time, whereas true allergens will spare us for first time, but it will make us to suffer for entire life. Coming to examples. What are the examples of true allergen? Now only I have mentioned peanuts, nuts, milk, eggs, shellfish like prawns. An allergen is dangerous to only those who are sensitive to these items. Rest all can eat safely how many times they want, but a sensitive person cannot eat them more than once. Drugs like beta-lactams, penicillins, amoxicillins, cephalosporins. That's why we should always ask whether they have any drug allergies before prescribing drugs. Antiepileptics, sulfonamides, inhalants like pollen, dust mites, animal dander, latex particles. These are all inhalants which are true allergens. They will go and bind to IgE antibody and stimulate mast cell. Venom from insect bites, insect stings. These can act as true allergen. These can stimulate alternative complement pathway. These can also stimulate our immunity and lead to formation of immune complexes. Coming to pseudo allergens like food additives, food colors, alcohol, spices, NSAIDs, mainly aspirin, opioids, radio contrast dye, vancomycin. We all heard of red man syndrome because of vancomycin. These are all pseudo allergens. No need of IgE antibodies at all. They will go directly and stimulate mast cell from the first exposure itself. Most dangerous. Coming to classification of chronic urticaria: chronic spontaneous and chronic inducible urticaria. If urticaria is developing on its own without any known external stimuli, it is spontaneous, chronic spontaneous urticaria. Previously we used to call chronic idiopathic urticaria, chronic autoimmune urticaria, but now those two terms are replaced by a bigger broad heading, chronic spontaneous urticaria. It may be due to autoimmunity or it may be idiopathic. We never know the cause, but we should always write it as chronic spontaneous urticaria. We can write subtypes like autoimmune chronic spontaneous urticaria or idiopathic chronic spontaneous urticaria. That's why I have written here clearly autoimmune chronic spontaneous urticaria. Chronic inducible urticaria. It is induced by physical stimuli like cold, heat, solar, vibratory, dermographism, delayed pressure. These are all leads to urticaria. If it is because of cold, cold urticaria, heat urticaria, solar urticaria, vibratory urticaria, dermatographism. If we stroke the skin with a blunt object, on that stroked area we will get erythema, edema. Other inducible causes are aquagenic urticaria. If we get exposed to water, irrespective of that temperature of the water, we will develop urticaria. That is aquagenic urticaria. Exercise induced urticaria, cholinergic urticaria, contact urticaria. If we come to contact with latex and if we develop urticaria, it is contact urticaria. Remember the channel name. Don't forget to like, share and subscribe. Thank you. Hasta la vista. До свидания.